with all the timers, but the post scalar operation is available only with timer 2 and timer 4. Okay. Then interrupt event, yes, interrupt event occurs upon the rollover, but here when occurs when it matches with the PR2 register. PR2 is a period register. Okay. And can wake the peak microcontroller from sleep. Sleep means when it goes into the sleep mode, whether the timer is used to make that from the sleep mode to the active mode. So timer 0 is not used, timer 1 and 3 can be used, but timer 2 and 4 also cannot be used for that purpose. So this slide is very very important. I will share this PPT, so you just do the comparative study on your own understanding, depending upon the different timers. And now see, each timer associated with how many registers I told? First register is a timer 0, a timer register where you put the values after calculations. TMR 0H and TMR 0L. These are the timer register. They are associated with all the 5 timers. Okay. Then control register. T0 con, T1 con, T2 con, likewise. So this register is associated with all the timers. And the flag bit. Flag bit is associated with all the timers. Okay. So this is the registers associated with the timers. Somewhat organization is different, but I have explained the organization for the timer 0. The same is for remaining timers. Okay. With some difference, but the bits associated with that is same in all the timer T con register, depending upon the timer number. Okay. So this is the comparison study. Then the CCP model, we have seen the feature of peak microcontroller is CCP. CCP stands for compare, capture and PWM. So right now we have seen key timer 2 is used for the PWM operation. So we'll see what is that registers associated with this. Now already I have discussed key for each and every peripheral, for each and every feature, there are registers associated with that. So first of all, you need to study the registers and then the operation. As far as this CCP is CCP module is considered, so these are the registers, or these are, you can call it as a SFRs associated with this. So CCP stands for compare, capture and PWM. So comparing the two quantities. Capturing means capturing any event from the sensor, capturing any event from the input devices. And PWM is, P stands for PWM, that can be generated to control the speed of the motor or control the intensity of light. So that is the feature of P. So we'll see the feature of PWM. Again, one CCP con register, control register is there. So as to control the operation of PWM, CCP1 con register. CCP1, why it is 1? Because two CCP modules are there. In that we will see CCP module 1. So CCP1 and CON stands for control registers. Okay. Then we have to load some values in the CCP register. So that registers are CCP-R1L, CCP-R1H, lower byte and higher byte. Okay. Then CCP2 con, the second model related to CCP model. So two control register related to that model. Okay. And the related registers to the CCP2 model, CCP-R2L, CCP-R2H. Okay. So here these first three registers are for CCP1 model and three registers are for CCP2 model. You can select any one at a time. Okay. So basically it is used under the CCP module, CCP module related to the peak microcontroller. Okay. And as the timer 2 is the basic timer for the PWM, that's why we should study the T2 con register, that is the timer 2 control register. TMR2 register, because it is a timer register, and only one register because it is 8 bit. If the 16-bit timer is there, then TMR2L, TMR2H, likewise registers are available. But as timer 2 is 8-bit register, only one register is available, TMR2. And PR2 register, that is the period register. Okay. So these are the three registers associated with the timer 2. Now we are concentrating on the pulse width modulation. So we'll see the diagram, just see the flow. Okay. Now what should be the duty cycle of your PWM signal? That is decided by the ccp con register is available in that fifth and fourth bit are corresponding to the duty cycle. Okay, then ccp r2l and r2h, so these are the two registers where you have to load the value. Then timer 2, this is the timer register of the timer 2. Then comparator is there, here also the comparator is there. Okay, now see what happens is when the timer starts counting, first of all it is compared with this pr2. Once it is compared, the flag is raised, and according to that the rs flip flop will get activated and the flag is generated. So it may be 1 and high depending upon the comparison state, and then you will get the high pulse. Again it will be resetted and again the same operation comes, then you will get the low pulse. So when the comparison is done by first comparator and second comparator, depending upon that you will get the high and low pulse. Afterwards I will show the simulation for the same. So this is the flow of the diagram so as to generate the pulse width. So the width of this particular pulse is equal to the pr2. That is the period register, whatever the value we are loaded in the pr2 register, that is the same, high pulse and low pulse. So in this way the duty cycle can be changed, and by the changing the duty cycle you can change the intensity, you can change the speed, whatever you want you can change that by changing the duty cycle. And for that purpose the bit number 5 and bit number 4 is responsible. So we'll see the ccp con register. So see, this is the ccp con register. In that bit number 4 and bit number 5, they are responsible, that is the highlighted bits, they are responsible for the duty cycle. So straightforward table is given in the book. So 000110 and 11 00 25%, 01 50%, 10 75%, and if these bits are 11 100% duty cycle is there, and remaining bits are the selection of the ccp model. So for that purpose remaining bits are available. So here you have to perform one practical depending upon the pwm to change the speed of the motor. So the calculation part we will see at the time of practical or at the time of program. Okay, so right now you have to just remember, as far as this timer is concerned, the 4 to 5 timers are available. How they are different from 8051 microcontroller is, in 8051 microcontroller the straightforward timers are there, so they are used to generate the delay and they are used to generate the they can be used as a counter. These two operations are performed by the timer. Here also these two operations are performed by the timer, but the pre-scaling factor, the pre-scaling facility is available in peak microcontroller, which is not available in 8051 microcontroller. So what do you mean by pre-scaling? By using the particular scaling factor you can increase the speed as well as you can increase the delay generation. So that is the beauty of the timer available in peak microcontroller. So according to that the remaining operation, so we have to load the initial value in the timer register, you have to start the timer. Once the timer started, it starts incrementing. When it reaches to the maximum value, it rollovers and the flag is generated. This all operation is same as that of your 8051 microcontroller. Only thing is here some of the timers are used for the pwm generation, that is not available in 8051 microcontroller. Some of the timers cannot be used as a counter, but here in 8051 both the two timers are there only, and both timers can be used for delay generation as well as can be used as a counter. Okay, so this is the comparative study between the timers of 8051 and peak microcontroller. So go through the timer part and just do the comparative study. So the basically the registers are more registered in peak microcontroller. So most of the cases the organization will not be asked in the theory exam, but you should know the organization. That's it. Okay, then we will see the interrupt part of the peak microcontroller. So as I said, The all the peripherals associated with the 8051 and peak microcontroller, they are same. So the basic working is same, but only the registers associated with that peripheral, or rather we can say the special function registers associated with that peripheral, they are different. So that's why we have to study only that register. Basic theory parts remain same, so I will not repeat what do you mean by interrupt, what do you mean by ISR, what do you mean by vector address. So all these part is covered in 8051. Okay, so as far as this peak microcontroller is concerned, basically there are three interrupts, or interrupt vector table holds the address of these three. Power on reset, that is the by default reset, it will be at 00h location. High priority interrupt and low priority interrupt, the only two categories there. So the address of this will be 008h location, and low priority 0018 location. So that is given in the diagram. So only these three interrupts are there, and the vector addresses are associated with these three interrupts. Okay, then all of you know, when the interrupt occurs, so what should be the steps the microcontroller follows? They are same as that of your 8051 microcontroller. So what is the change in? So so as to come back from the interrupt routine, which instruction should be there in the ISR in 8051 microcontroller? What is the instruction we have seen? Yes, in interrupt service routine, when the interrupt is generated, the interrupt control will be transferred to ISR routine. The executions, whatever the instructions are there, they will get executed. So when how it come back from ISR routine to the main program, what should be the instruction written in the ISR routine? Yes, काय इन्स्ट्रक्शन असे असते तिथे की जेणेकरून तो कंट्रोल मेन प्रोग्रामला स्विच होईल? दर्शना, हॅलो.
Return.
Written is for only basic subroutine, na? When the control is transferred to any subroutine, and from that subroutine to main program, how the control is switched? By using the RET instruction. But as far as this interrupt routine is concerned, the routine is available in ISR, interrupt service routine. So what instruction is written at the last? Yes, Darshana? Darshana, are you there?
Yes, ma'am.
So, forgot everything.
मैम मैम रिटर्न ही था, पर इंटरप्ट का याद नहीं आ रहा.
RETI, that is written
हाँ
from interrupt. Simple
हाँ
instruction.
हाँ
So
हाँ.
if you forgot this now, you will not understand the uh, basics related to the peak microcontroller, and that's why I'm doing the comparative thing. So it should not happen likewise, otherwise you will not get anything, and you feel this subject is very difficult. So see, it is up to you. So the thing is, only this is different. Here it is RETFIE. So this instruction is there. Okay, and then the remaining steps are same. Suppose the microcontroller does the first of all executes the main program. When interrupt is generated, it will just store the next instruction address onto the stack. It will go to the ISR. A ISR routine will be get executed. At the end of the ISR, there will be a return from interrupt routine instruction. Here the instruction is somewhat different, RETFIE. Then it will just pop up the content from the stack, and then the control is transferred to the main program. This is same as that of your 8051 microcontroller. Steps are same, only in ISR what should be the instruction? RETFIE, that's it, nothing else. Okay, so these are the steps in executing the interrupt. So we will see All interrupts are masked, that is the disable. Non-mask and mask in, category we have studied. The interrupt which are disable, which the interrupts which cannot be disabled. Okay, the reset interrupt. Then the most important thing is in 8051 microcontroller, only interrupt flag bit is available. So here the flag bit is available, the enable bit is available with each and every interrupt, and the priority bit is available. Means for single interrupt, 3 bits are associated with the each and every interrupt, so the number of bit becomes more. Okay, so flag bit is just to indicate that interrupt event occurred. Enable is means whether you first of all you had to enable that interrupt before using it. If it is not enabled, we cannot use, the controller will not give the service to that particular interrupt. Okay, and the priority is depending upon the high and low priority set. If it is decided according to that, the interrupt will be service. So for each and every interrupt, these 3 bits are associated in peak microcontroller, whereas these 3 bits are not available in 8051 microcontroller. Okay, so this intcon is very very important register in that, uh, so as to enable the interrupt in 8051, only 1 bit is available. So here first of all, 2 bits are available, that is first bit is global interrupt enable bit. So disable all interrupts at a time if it is 0. Okay, so if gi is equal to 0, no interrupt is acknowledged even if they are enabled individually. Means what? One interrupt enable bit is global interrupt enable, which is available to all the interrupts, and each interrupt is having a individual enable bit. Suppose I want a timer 0 interrupt, so I have enabled the individual timer enable bit, interrupt enable bit, but gi bit is 0, but still that interrupt cannot be acknowledged. Means first of all, gi bit should be 1, and then you have to enable the individual interrupt bit, individual interrupt enable bit. Okay, so see, it is written, if gi is equal to 1, interrupts are allowed to happen. Each interrupt source is enabled by setting the corresponding interrupt enable bit. Each interrupt has a individual enable bit, but all the interrupt has global interrupt enable bit. So when you want to use any interrupt, or when you want any service from the microcontroller for that particular interrupt, GIE bit must be 1. Then and then only you can use that particular individual interrupt. Okay, means so as to use any interrupt acknowledgement, first of all gi bit should be 1, and then that individual interrupt enable bit should be enabled. Then and then only the service is provided. Okay, are you getting this feature? What is the meaning of GIE? Same as that of your global declaration and local declaration. Yes, in C programming, the concept is same as that of the global and local declaration. Okay, then this is known to you, TMR0IE and INT0IE. So these 2 bits are available in this intercon register, that is the timer 0 interrupt enable and external interrupt 0 enable bit. Means here, as I told, for each and every interrupt bit, enable bit is available, flag bit is available, and priority bit is available. So that's why number of bits are there as far as this interrupt structure is concerned. And peripheral interrupt enable bit is also there. So we'll see the diagram, then you will get the idea. Now see the diagram carefully. This is the very very important and basic diagram related to the interrupt. So what is written? Suppose some of the interrupts are categorized in the core interrupt, peripheral interrupt. Now when this is 1, then the interrupt will be service. So as to make this 1, this should be 1, this should be 1. So as to make this 1, either of this should be 1. Okay, so as to make this as a 1, this should be 1, and this should be 1, because this is a AND gate. Okay, So according to that, number of interrupts are there: timer interrupt, serial communication interrupt, then recess is a by default interrupt. So according to that, then ADC interrupt, or once the A to D conversion is open happens, the interrupt is generated. So likewise, all the interrupts are categorized as core interrupts and peripheral interrupt. So each interrupt has associated with the enable bit that you have to enable. Then peripheral interrupt enable bit is also should be 1. Then and then only this AND gate will be 1. So if this is 1 and if this is 0, so it will be 1. So one of the input of AND gate is 1, and so as to make all these as a enable GI, see the position of GI, not at the initial stage, at the last stage. So GI must be 1. Then and then only the particular interrupt will be get service. So suppose this is a low priority interrupt, then the interrupt will be available at vector address 0008 location. Are you getting the meaning of PIE and GIE bit? PIE is the peripheral interrupt enable bit. GIE is the global interrupt enable bit, and individual timer has timer 0 interrupt enable bit, timer 1 interrupt enable bit, serial communication interrupt enable bit, A to D interrupt enable bit. Are you getting this concept clearly? Just tell me. It is very, very simple but somewhat vast or lengthier one. Yes? Pranali, Sumit, yes?
Yes, ma'am.
So each interrupt is associated with the individual enable bit. For peripheral interrupt bit, separate enable bit is available, and so as to make all the interrupts to be enabled, the GIE bit, global interrupt enable bit, is available. So you can see by the help of this flow of the diagram, unless and until GIE bit is 1, your AND gate output will be 0 and no interrupt will be serviced. So that is the basic meaning of this. So this is very important diagram. Remaining are same as that of your previous, but this is very, very important diagram as far as the interrupt is considered. Okay. So three categories there: high priority, then the reset, and the low priority interrupt. So see here it is given IP, IE, and IF means what? Priority bit, enable bit, and flag bit associated with the each interrupt. So legacy mode means if the priority is not matter at all, and priority mode means the priority is considered. Okay. So here highest priority and lowest priority. Otherwise, the reset will be the by default interrupt. So this is not actually important. This is very, very important diagram as far as the interrupt is considered. Okay. Now see, I will show you the diagram. So see, these are the interrupt bits associated with each peripheral. Now see, if it is timer 0, timer 0 IF, TMR 0 IE, means for timer 0, how many bits are there here? In 2 bits, and one more bit is TMR 0 IP, priority bit. Okay. Then timer 1, TMR 1 IF, flag bit, and enable bit. TMR 2, flag bit, enable bit. TMR 3, flag bit, enable bit. And what this is written? These bits are available in these registers: intcon register, PIR1 register. This timer 2 IF is also available in PIR1 register, and timer 3 IF is available in PIR3 register. And here also the enable bits are available again in these registers. So the timers, their flag bits, they are available in these registers at any position, enable bits, and they are available in these registers. Are you getting this table? Yes. Everyone is getting this table? Yes. Ho nahi bula.
Yes, ma'am.
I'm showing the timer table and the
Yes,
timer
ma'am.
interrupt, timer flag bits, timer enable bits, and the registers means these flag bits available in these registers. register organization. Suppose see, the incon register organization is shown, the TMR0IE and TMR0IF. TMR0IF and TMR0IE, they are available in the intcon register. So here is the intcon register organization. Remaining bits are also available, but they have shown only the timer 0 bits available in intcon register. Somewhat vast, means number of registers you have to remember, but it is very simple. That's why I have made the table. So these are the timer interrupts. Now we will see. So this is the diagram related to the timer. You will understand the timer interrupts. So for that purpose, the peripheral interrupt should be enabled, and at last GI interrupt should be enabled. Then the these timers, one of the timer interrupts can be serviced. Okay. Then see, this is the serial communication interrupts. So for serial communication, TX and R, instead of RX, RC is available. Only 2 bits are available. So their flag bits, their enable bits, and they are available in these register. That's it. Means what I told in earlier slide is, each interrupt is having the 3 bits associated with that. One is flag bit, one is enable bit, and one is priority bit. Okay. So this is the diagram. Again, the same diagram, only serial communication flag bits or enable bits they have taken, and these 2 important pins, that is peripheral interrupt enable and global interrupt enable. And we have seen one simple program. So I have explained this code now. Yes. If you
Yes,
understand
ma'am.
this code, you can understand the further course, remaining course. So very simple. Simple LED interfacing. So this is the diagram. LEDs are connected to the port B. Then the register value calculation, and that's why I use the port B, tris B. So yesterday, that is the Tuesday, and today's lecture we have covered the so many topics. Just go through the book, try to understand the concept. Don't bother about the register organization, huh? So try to understand the concept, try to relate the registers associated with that, and try to summarize the topic, and try to compare that points with 805 microcontroller associated point. Then you will understand both microcontrollers properly. Okay. So what we have studied from the last lecture is, we have completed the port structure, we have completed the pin diagram, we have completed the timer part, we have completed the PWM part, and we have completed the interrupt part. In the previous lecture, we have completed the memory organization, we have completed the architecture, then we have completed the status register. So see, things are very simple, but they are just vast, means number of things you have to study at a time. That's why you feel this is difficult, nothing else. But the basic topics are not as such difficult. So I already told to contact your librarian madam, because the Nimbus software is available. You will be provided with username and password. You can access all the e-books from there. So already I have given the idea for the same, and the remaining part available related to the peak microcontroller. Basically those are the theoretical part you have to study on your own, but the things which are new to you, I will be covering that topic in the further lectures. Till now, any doubt, any confusion? But for that purpose, initially you have to study first, then you will get the doubts, or there will be a problem with any topic related to the peak microcontroller. Yes. Now see, if you understand this basic thing, now the first program is LCD interfacing with peak microcontroller. So already you are aware of LCD, you are aware of the pin diagram of LCD. How to connect the LCD to the microcontroller, peak microcontroller, that is also known, same as that of your 8051. You can connect to any port pin depending upon the LCD's port pin. I will explain directly the code, that is the C code. Similarly, LED interfacing. So second practical, two practicals, LED interfacing, LCD interfacing. Then ADC, then serial communication, and somewhat PWM and I2C, that is EPROM and RTC. I think two practicals are there. So these peripherals are remain, that will be covered in the practical session. Yes. Do you feel the peak microcontroller is boring or complicated? So see, don't think likewise, otherwise you will not understand anything, because you have just make your mindset likewise, made your mindset likewise ki, yes, this is a very difficult microcontroller. Try to study with comparison and try to understand the basic things. The things are very very simple. Right now I told you number of resistors you need to study, so as to study a individual peripheral, so that's why you are feeling it's very difficult. For timer in 8051, only two timers are there and only four registers are there. But here in each timer, three registers you need to study, and such four timers are there. 4 to 5 timers are there. So obviously, the number of registers are more. But if you do the smart way by logic, if you remember the registers, then it will be very easy. Yes, any doubt, any difficulty?
No, ma'am.
Sure. Do you have the book?
मैम ऑनलाइन है, ऑनलाइन पीडीएफ है बुक का.
PDF है ना? But still, now I will just give the task to the Suyesh or Tejveer. You can also take the feedback from the student. Those who want to come to college willingly, not compulsory. Are you getting the point?
Yes, ma'am.
Those who want to come to the college for the hardware practical. So before today 5 p.m. you have to submit the list. Just contact with Suyesh after this lecture. We will make the list. We will just divide that student into the batches. I think your DC subject, your MC subject, and your mechatronics subject have the hardware practical. So that practical schedule will be planned. We will plan the practical schedule in a single day. Suppose, for example, those who are at their hometown, no need to come. Those who are localites, and if their parents permits to come to the college, then and then only you have to come, because while coming to the college you have to come with your consent letter with the parent signature to the HOD. And parent, my ward is studying in TE and TSC, and I'm allowing that ward to come to the college for the practical purpose, and this is my undertaking letter. So ऐसे लिख के matter लिख के you have to take the signature of your parent, and you have to while coming to the college you have to submit that consent letter. Are you getting, Tejveer?
Yes, ma'am.
So this is the condition, and we will complete that practicals offline with only 10 students are required per batch, and that video we will share to the other students. Is it okay?
Okay, ma'am.
Yes,
Yeah.
ma'am. That is
If you
only the
want,
need.
you can. If you want, you can help your friends afterwards when you come to the college. If you physically performs all the practicals, you will get the idea, you will get the knowledge about that. And if your friends are finding any difficulty, rather you should help to your friends, those who are at remote locations. Okay.
Okay, ma'am.
So Tejveer, just make a list, those who are in Pune, and with the consent
But
letter of
which date,
parent.
ma'am?
Dates may be in the next week. We will just
Okay.
convey the dates, I think from 16 to 18. Probable dates, huh? But you have to come only for one day.
Okay, ma'am.
In a single day, we will plan the 2 hour session, and the batch will be circulated, but whole day you have to wait. You have to be in the college. Okay.
Okay,
Suppose
ma'am.
the 30 students are willing to come to the college, we will make the three batches, T1, T2, T3. T1, all batches of 10 students. So T1 will go to the MC, T2 will go to the mechatronics, and T3 will go to the DC. And then afterwards we will swap. In this way, 2 2 hours each batch will perform the practical. Are you getting?
Yes, ma'am.
So just contact with Suyash also, and by the 5 o'clock, I want the student list, roll number and student name, and you have to
Yes,
ask
ma'am.
your parents also. Yes.
Yes, ma'am.
And without consent letter, we will not allow you to perform the practical. So first of all, take the list of the students those are willing to come to the college. Then we will decide and convey the further schedule. Okay. Okay. So
Yes, ma'am.
we'll complete the serial communication part and then we will stop. So see, this part is also covered, already covered. What do you mean by communication, asynchronous communication, duplex, the framing? So what is different here is what are the registers associated in serial communication in peak microcontroller. Okay. So it is having the user, universal synchronous asynchronous receiver and transmitter. So 6 registers are associated with this. So spbrg, txreg, rcreg, txsta and rcsta and pir1. So first of all, just understand the registers, then I will just tell you detail meaning of each and every register. Okay. So basically, as far as the baud rate is concerned, SPBRG register is available. So for peak 8051 microcontroller, what was the register for baud rate? Do you remember? Yes. असं केल्यावर कसं व्हायचं रे?
Ma'am, can you repeat, ma'am? Okay, आवाज
For
टूट गई.
8051 microcontroller, what was the register, baud rate register?
9600, ma'am.
Baud rate value. So where you do the calculation, where you store, save, store that calculations.
Pecan.
Tcon is the control register, no? You have to search that. I will not tell now. Now see, SPBRG is the register where you have to load the baud rate. So number of baud rates are there, and basically we will prefer the 9600. But what value should be loaded in SPBRG register so as to get this baud rate value, that is written here. Okay, and the calculations are done by this formula. So this is very very simple. So you can do that, and the table is available. But we always we are with the 9600 baud rate. Okay. So SPBRG is a register where you load the baud rate value. So the calculations are done.
So it will be S buff, right?
SBUF is the register where you load the value, initial value for the calculation. Okay, for timer register by calculation of that all the 9600 baud rate. Yes. Next, the TXREG register. Now see, what we do in 8051 is whatever you want to transmit, that is loaded in SBUF register. Whatever you receive, that is also available in SBUF register. Do you remember this? So when I put basically SBUF is a simple register, 8-bit register where you store the value which is to be transferred. Okay. So here for both the operations, separate register is available. Okay. TXREG. So the byte of data to be transmitted via TX pin, it must be placed in TXREG register first. Are you getting the meaning? Tejveer, what is the job of SBUF register? whatever letter you want to transmit, suppose a character, a letter, that is to be stored in SBUF register. But the same register in peak microcontroller is TXREG register. Okay, so TXREG register is used to store the data to be transferred. Suppose I want to transfer a letter A, that is stored in a TXREG register, transmit register, where the data is to be loaded. Now RCREG register. So what I told just now, ki, in 8051 microcontroller, so as to transmit the data, any data, whichever data you want to transmit, that is stored in SBUF. And while receiving also, whatever data is received, that is received in SBUF register. Only one register is available in 8051 microcontroller. But here, for transmission, the data is loaded in TX register, while reception, the data is available in RCREG register. Are you getting this concept? Two separate registers are available in peak microcontroller for transmitting as well as receiving. Are you getting?
Yes, ma'am.
And these two registers, the job of these two register is performed in 8051 microcontroller by same register, single register, that is SBUF register. Okay, so whatever data you want to transmit, you have to load in SBUF register. Whatever data you want to receive, that data is available in SBUF register. But here, whatever data you want to transmit by peak microcontroller, that is to be loaded in TXREG register. But whatever data you want to receive, that is available in RCREG register. Means while reception, you will read, the user will read the RCREG register, and while transmission, user will load in TXREG register. This is as simple as the register thing. Okay, and the control register, the status and control register is available, same as that of your SCON register in 8051 microcontroller. Okay, so the different modes are there, the synchronous mode, asynchronous mode, what type of transmission, 9-bit or 8-bit, so associated bits are there. The different bits I will just explain. TXEN is most important bit in this. What is the TXEN bit? Transmit enable bit. So you have to make this bit always one, otherwise the transmission should not be happen. Okay, the transmission will not happen, so that's why transmit enable bit, that is TXEN bit, should be 1. If it is 0, transmission will be disabled. Okay, the next, the basically again this is for synchronous and asynchronous mode. Then most important bit is BRGH, that is the high baud rate select bit. So we have seen at the time of 8051 also, when you want the high speed and low speed, this particular bit will be selected from TXSTA register. And the TRMT bit is also available, transmit shift register status bit. This is same as that of your TX flag, that is the whether the transmission is completed or not. How you come to know? The flag, inter flag bit is available in 8051. Here also transmit shift register status bit is available. The TSR is an internal register which is not accessible to the user, whether that is empty or whether that is full. From that you come to know the transmission is completed or not completed. So which are the important bit? Remaining bits explanation is given: TXEN bit, BRGH bit, and TRMT bit. So this is the TXSTA register, that is transmit status and control register. So it will control the communication as well as provide the status. What type of status it will provide? Whether the transmission is completed or not. Okay, so same as that of for reception also, the same register, say different register is there for showing the status of transmission, and for controlling the transmission status, transmission operation, the TXSTA register is available. But for reception, showing the status of reception or controlling the receiving action, the RCSTA register is available. TX for transmission, RC for reception. Okay, whereas in 8051, TX and RX bits are available. Okay, so here also the important thing is receive enable, that is SREN bit is available, that is single receive enable bit, that is available only in synchronous mode. And we have seen some of the errors related to the reception or transmission, that bits are related to the error bits are available in RCSTA register. But when the reception is occurred, when the reception is data is received, that data is available in RCREG register. So we have to just read this data, that is RCREG register, when reception is occurred. So these are the registers associated with this. Whatever the registers we have seen, what are the different registers we have seen? SPBRG register for baud rate value to be loaded according to the calculation. TXREG register, when you want to transmit any data, that data is to be loaded in TXREG register. When you receive the data through the microcontroller, the data is available in RCREG register, so as to give the status of transmission activity and control the transmission activity. TXSTA register is available, so as to give the status of reception and so as to control the receiving activity. RCSTA register is available, and the inter flag bits are available in PIR1 register. So we'll see that PIR1 register. See, when the data is transmitted or not, how you come to know? The transmit flag is available. When the data is received or not, reception flag is available in 8051. Here also these two flag bits are available. So see, the things are very simple, but just they are lengthier one. So when data is transmitted, the data is properly transmitted or not, that will be given, that status is provided by transmit interrupt flag. And whether the data is available for reception, that data, that status is provided by receive interrupt flag bit. So if it is 1, the UART has received a byte of data, it is sitting in the RCREG register waiting to be picked up. So upon reading RCREG register, RCIF is to be cleared to allow to the next bit to be received. It is same as that of your same serial communication in 8051. Only the bit available in 8051 is different. For reception, whether the data is received, received properly, that is given by RCRF flag. Whether the data is transmitted successfully, that status is given by transmit interrupt flag bit. So if it is 0, TXREG register is full, means the data is not transmit successfully because it is full. We have stored the data in TXREG register, that is full, means data is not transmitted. If it is 1, TXREG register is empty, means the data is successfully transmitted and user can transmit the next possible data. Okay, so these are the two flag bits available in PIR1 register. So we have seen all these register, all the 6 registers are available, but they are very very simple, don't bother. Now for serial communication, you have to remember these 6 registers. But for timer, each timer is having the 3 registers. Okay. So the steps are given. Now what should be the value of TXSTA register? We have calculated the SCON register, it is 20. So just check how it comes 20. TXSTA register. 0, 0, this should be 1, this should be 0, and all bits are 0, 0. 2, 0 means I want only, that's why I told this is an important bit. The remaining bits are not at all required for the simple programming. Okay. So First of all, you have to make the status register value by selecting a particular mode. So what is this indicating? Asynchronous mode, 8-bit data frame, low baud rate and transmit enable bit. Depending upon that, the particular values are made 1 and 0. You will get 20 as a value. Set TX pin as a output pin, that is a RC6 pin. Okay, how to set this pin as a output pin? By using the trace register. Okay, then load the SPBRG register for the baud rate. So you have to load one of this value. Basically, we want 9600, so F value will be loaded in SPBRG register. Then enable the serial port SPEN in RCST register. So that is very important for our reception as well as transmission. This bit should be enabled. And the character byte to be transmitted must be written in TXREG register. So right now I told whatever bit you want to transmit, that should be stored in TXREG register. And once the bit is loaded, which is to be transmitted, which you want to transmit is loaded in TXREG register, what is the job of user? Just keep monitoring this TXIF flag. That's it. Once that bit becomes 1, means the data is transmitted successfully. If you want continuously to transmit the same bit, you can go to the previous step. Otherwise, you will stop the sending any data. Okay, so these are the steps just given for the serial communication, that is for transmission, and same for the reception. Same for the reception. So how the reception 90 comes? RC STA register. So 1001 and 0000. So this bit is 1 as well as this bit is 1. That is SPEN, serial port enable bit, and CREN, that is the continuous receive enable bit. Both should be 1 and remaining all bits are 0. So that becomes 1001, that is 9, and 0000, that is 0. So that's why for reception RCSTA should be 90, TXSTA register should be 00. To choose the low baud rate operation, then load the SPBRG register. For reception also, at what baud rate the data is receiving. So obviously you have to load the baud rate value. Set RX pin as an input pin because we are receiving the data to the pin. So that pin should be act as an input. And just keep monitor the RCRF flag. This flag is 1. It indicates that the data is available in RCREG register. So read the RCREG and move RCREG data to any other safe place or any other register. That's it. And if you want continuous process, again go back to the starting position. Yes. So these are the two parts related to the serial communication, that is reception and transmission. So these are very simple thing. Just go through that. Today I will just share all the PPTs. Try to read the PPTs, try to understand the concept. Otherwise there will be burden of lot of things of peak microcontroller. So side by side you just complete all the topics once it is completed in the lecture. Okay. Now lastly I will show one diagram. That's it. So see, this is the simplified user transmit block diagram. So this is the interrupt flag. This is TXREG register where you load the data. This is a TSR register. So this register is internal register. It is not accessible with the user. User cannot access this register. Then SPEN, serial port enable bit, is available, and the pin is also available for transmitting. Through this pin the data is transmitted. Then SPBRG, one of the input is NAND gate and it is given to the TSR. So first of all you have to set the bit, you have to set the baud rate, then the data is to be loaded in TXREG register. It will go to the TSR register, and then through this setting, that is serial port enable bit, through TX pin it will be transmitted. Once it is transmitted, the TXIF flag will get raised. So now see, TXIF flag will get raised. For that purpose TXIE flag should be enabled. Then and then only the interrupt will be, the AND gate output will be 1. Okay, so this is the significance of flag bits, that is flag bit, enable bit and priority bit. The priority bit is very rarely required because Depending if the number of things are happening at the same time, then and then only we could think of the priority. Otherwise, that bit is only available wherever you require, you can use that bit. But these are the two important bits related to the interrupt: flag bit and enable bit. That's it. So this is about the serial communication. What we have seen is the what are the different registers associated with the serial communication. Then what is the baud rate? The table is given already. The SPBRG register is for the baud rate. TXREG register is for the transmission. RCREG register is for the reception. TXSTA is the register to show the status and control the transmission operation. RCSTA register is to show the status of reception as well as control the reception activity, and PIR1 register where the reception interrupt flag and transmission interrupt flag bits are available. Then we have seen the steps or algorithm for transmission of data and algorithm for reception of data. That's it. Any doubt regarding this? This is very simple if you are just remembering the serial communication part of 8051 microcontroller. See, if you correlate the things are very same as that of your basic operation is very same as that of your 8051 microcontroller. Only registers associated with peak microcontroller, they are different. And if you correlate the resistors, then there will be no confusion between both the microcontrollers. So that's why at the time of 8051, I already told that the theory remains same. Only what will be the change in peak microcontroller is different resistors are available. That's it. Yes, any doubt, any confusion, anything which is not understood? Today just remember me. No doubt I will just mail all the ppts, but if I are not mail, just put the message. I will share all the material related to the peak microcontroller. I have the data sheet also, I will share that also. Yes. So should I stop now today? This much is sufficient? अजून एखादा एक तास घ्यायचा? येस. हो किंवा नाही तरी म्हणा. काहीच नाही
Ma'am,
बोललाय
so
म्हणजे तुम्हाला चालणार आहे अजून एक तास? हा, बोल दर्शना.
ma'am, this one is sufficient. This much.
ओके, दिस मच लक्षात आलंय ना? पण पीपीटी
Yes,
पाठवते,
ma'am.
वाचून घ्या, नाही कळलं तर विचारा. ठीक आहे, मला
Yes,
अटेंडन्स
ma'am.
द्या. टुडे इज 10 ना?
Yes, ma'am. 10 December.
हा, मग एकेकाने रोल नंबर सांगा आणि लेफ्ट झालात तरी चालेल.
Ma'am, 56.
56. ओके, नेक्स्ट.
7.
7. हर्षल,
Six.
व्हॉट्स
Oh,
युअर
7.
किती?
7, 7.
7. ओके, ठीक आहे. हा,
Ma'am, roll number 6.
ओके. हा, नेक्स्ट.
63.
ओके, नेक्स्ट.
21.
21 इज ओके. हा, नेक्स्ट. I'll
59.
mark the 59. Okay.
26.
Okay.
69.
69. Okay.
47.
Okay. Kaid, what's your number? Sumit?
मॅम 66 नंबर झाला ना मॅम
नाही झाला
66
66. आणि तो कैद रावलचा काय नंबर आहे रे? तो फक्त ऑनलाईन बसून दुसरं काम करतोय वाटतं.
माहित नाही मॅम त्याचा नंबर बट
ठीक आहे, चालेल. ओके,
थँक्यू मॅम.
ओके.
एक्सक्यूज मी मॅम.
हा
मॅम अटेंडन्स झाली का? टाइमला
काय
लेफ्ट
करत
झाले.
होती?
रेंज
काय
गेली.
नंबर आहे?
58.
58.
हा.
ओके. त्या कैदचा काय नंबर आहे माहिती का? रावळचा.
कोण?
कैद रावळ आहे बघा, एक दोघच आहेत आता तुम्ही.
माहित नाही.
ठीक आहे, चालेल. ओके. खाली नाही या जरा. काय नंबर? 937 37 34 28 950. का बरं नाहीये मॉडेल प्रमाणे? नाही, त्यांनी कंबाईन केलेत ना. हा एक झाला. आणि 27 हा एक. इथं मग त्यांनी काय केलेलं असणार आहे? विचारून घ्या मग त्यांच्याशी. तसं द्या म्हणा बिल. बिल तिथं ना काय? तुझं बिल पाहिजे म्हणल्यावर त्याचं बिल झालं काय? त्या लॅब असिस्टंट करतील आता एंट्री. माझ्या लॅबला काय आहे? माझ्या लॅबला काहीच नाही टाकलं. यंत्रा फोन करून घ्या त्यांना म्हणा आम्हाला. त्याला काय म्हणा, आम्हाला तुमचं बिल लवकर प्रोसेस होईल, लवकर करून द्या म्हणा त्याच्याप्रमाणे. नाहीतर काय कन्फ्युजन असेल तर सांगा म्हणा तसं.